Hello everyone, I am Seshavidya, working as Associate Professor in the Department of Electronics and Communication Engineering at R.M.K College of Engineering and Technology. So today we are going to discuss encoder. So what is encoder? So encoder, it's actually a digital circuit, so which will perform the inverse operation of decoder. So in the last video we discussed about a decoder and its application, which will perform the inverse operation. And this encoder, which will have 2 power n input lines and n output lines. So which will have and enable inputs too. So this various implementation of this encoder is, and first one is octal to binary encoder and second one is priority encoder. So this encoder which will have 2 power n data inputs and n data outputs. So let us discuss octal to binary encoder and then encoder. So octal to binary encoder, how to design this octal to binary encoder. So in this octal to binary, so the name itself octal, so it will have 8 inputs. Okay, one for each of the octal digit, so that it is 8 inputs. And binary encoder, which will have 3 outputs. So that this octal to binary encoder, which is also called as 8 to 3 line encoder. And here what is the only one condition is that in case of binary encoder, we have to always assume that only one input should have the 1 at any given time. That is, only one input should be active at a time. Otherwise the circuit has no meaning. So this is the circuit diagram of octal, that is a truth table. First you have to construct the truth table for octal to binary. As I told you, octal means which will have 8 inputs. So I'm just writing from D0 to D7, and which will have 3 outputs, binary outputs A, B, C. So as I told you, this encoder at a time only one input should be active at a time. So in the first row only the D0 is equal to 1, the remaining and all 0. So that the corresponding output will be all 3 zeros. In the second row, only the D1 is equal to 1, the remaining inputs and all 0. So D1, the subscript is 1, so that the 3-bit equivalent is nothing but 0, 0, 1. So similar way, we can just construct the truth table. Now by using the, what is that output from this truth table is, and this encoder that can be implemented by using OR gates. Okay, that is the inputs are the inputs that can be determined from the truth table. Now if you just look into that output column, that is A column alone. So this output A is equal to 1 for the corresponding inputs. What are the inputs? D4, D5, D6, D7. So that we can write it as output A is equal to sum of D4, D5, D6, D7. Similar way, the output B that can be written as D2 plus D3 plus D6 plus D7 from the truth table. Similarly, we can just write it for C also. Now we can just draw the logic diagram for this octal to binary encoder. So this is the logic diagram. So X value, Y and Z inputs are from D0 to D7. So simply we'll be connecting OR gate so that we can just get the output X, Y and Z. Next one is priority encoder. So what is priority encoder? Why we go for this priority encoder? Why? Because as I told you in that encoder, at a time only one input should be active. Suppose say for example, more than one input is equal to 1 at a time. So in that case, what should be the output of encoder? So there we have to just use the priority function, which means either we can just use the higher priority or lower priority. So in this case, we are going to use higher priority function, which means at a time both the inputs are more than one input is equal to 1, which will just give the preference for the highest priority function alone. Okay, so let me explain that one. So this is a truth table for the higher priority encoder. Inputs are D0, D1, D2, D3. Outputs are X and Y. Actual outputs are X and Y. And there is one more output called V, that is also called as validator. So which will indicates that whether that actual input is given to the circuit or not. When the validator is equal to 0, which means the actual input is not given. That is without giving any input. And suppose if the validator is equal to 1, which means the actual output is given to the circuit, so that what you are getting, that output at the X and Y is nothing but the actual outputs. So that is nothing but validator. Now inputs D0, D1, D2, D3. So in the first row we will be considering all 4 zeros, and validator, since validator is equal to 0, so no need to bother about this X and Y. Why? Because this validator is equal to 0. This is not the actual input to the encoder. So in the second row, only the D0 is equal to 1, the remaining inputs and all 0. So and at the same time validator is equal to 1, which means the actual input is given to the encoder, so that which will proceed on. So since D0 is equal to 1, the subscript is 0. So therefore, we'll be getting that output as 0 equivalent in terms of 2 bits. That is 0, 0. In that second, that is third row, and here D0 is equal to X and D1 is equal to 1. Just assume that both D0 and D1 is equal to 1. That is, at a time both the inputs are active. So if it is the case, what will happen is, as I told you, which will take the highest priority, which means which will compare D0 and D1. Please look into that subscript. This D1 is higher than that of 0. So obviously, which will consider it as D1 is equal to 1 as an input, so that the corresponding output will be 0, 1. Irrespective of D0, it may be either 0 or it may be 1. Similar way in that next row, X and D2 is equal to 1. Suppose assume that 1, 1, 1. If it is the case, that is more than one input is active at a time. If it is the case, again which will compare all three inputs. So by comparing this D0, D1, D2, which has the highest priority, obviously D2 it has the highest priority. So that which will take D2 is equal to 1 as an input, so that the corresponding output will be 1, 0. So likewise, which will give the output. Similar way, the last row, all 3x and last one is 1. Assume that all 4 ones is given as an input. If it is the case, obviously D3 it has the highest priority when compared to the D0, D1 and D2. So that the 3 equivalent in terms of 2 bit is 1, 1. So likewise, we'll be getting that output. Now what we are going to do is, we are going to use the K-map. By using this K-map, we are going to find the Boolean expression for output X, Y and V. So next will be K-map simplification. So here what you have to do? So X is equal to, so first we are going to consider this column, X column alone. So wherever that X is equal to 1, that combination that can be represented in the K-map. So X is equal to 1 for the combination X, X, 1, 0, which means in this XX, as I told you, it may be either 0 or 1. Since two variables are unknown values, so which will have the 4 combinations, that is, both may be 0, 0, or it may be 0, 1, or it may be 1, 0, or it may be 1, 1. So all 4 combinations that has to be represented in the K-map. And similarly, this X output X is equal to 1 for the combination 3x and 1. So 3x means 3 X values are unknown. That is, it may be either 0 or 1. So there are 3 variables unknown means which will have the 8 combinations. That is starting from 0, 0, 0 to 1, 1, 1. So that is, we have to consider all 8 combinations together, and that has to be represented in the K-map. So finally, you can just do the grouping so that we can just find out what is X is equal to. So from this, we'll be getting it as X is equal to D2 plus D3. Similar way, we can just do it for Y as well as for the validator V. So we'll be getting that expression for Y as well as V. So what should be the last step? Obviously, we should draw the diagram for the obtained expression. So this is the expression X, Y and V, what we just got it from that K-map, so that we can just draw the logic diagram. So this is about the priority encoder. So if you just come to that application point of view, that is where we can just use this encoder. What is the purpose of this one? So generally speaking, this the encoders which will convert the any data, that is data from one form to the another. That is especially if you want to say, and we'll be using that encoders in the communication systems like telecommunication, networking and transfer of data. Okay, that is which will translate the rotary or linear motion into a digital signal. And that signal that can be given to the controller, which monitors the motion parameters like speed, direction, position and so on. So this is the real-time application of encoder. So most probably we'll be using in that communication system. So I hope you understood that what is encoder. Thank you.